Alright, it seems we are live. Continuing on with the component placement of this motor controller board. In the previous videos I have I've grouped certain parts of the board together, for example like this power supply. And the way I like to do this, this initial placement, is to actually group things and enclose them in kind of like a small box, which I draw on the silk screen. And this results in basically like smaller boards, which I can then arrange into one big board. And in KiCad, this is a good way to arrange things, because it allows also square selection like this, or rectangular selection. So in this video, I will continue with the CAN interfaces. I will lay out the CAN 2B and the CAN-FD / CAN 2B. And this will hopefully get rid of some of the some more components. Let's see. Let's start with the first CAN 2B interface and move it out. And basically, the initial placement is just moving the components, basically grouping the components. It would have been very useful if KiCad had a functionality that allowed like selecting several components in the schematic and then automatically sort of selecting them on the PCB so that they could be moved out. But as far as I know, KiCad doesn't have that functionality right now, so I have to do it this way. And the connector, let's actually move both connectors. And this connector, I can see right away that this is old version of the connector. It was when I assumed that I would have 5 millimeters of the connector hanging outside the PCB. But then I later decided that it would be better if the end of this connector would be aligned with the PCB edge. So I'm going to update this this footprint so that we have a correct silk screen around it. I'm going to open it in the footprint editor. Let me just check something, because there is one thing that that is easy to mess up, and that's if you, for example, have a footprint which you haven't updated, and you then open it in the footprint editor and you save, and then you overwrite your new footprint with the old version that is from the PCB editor. So it's important to update the footprint first. So we update the footprint, and now we know that this is the version from the library. So we can open it in the footprint editor, and then when we save it, we can update again and get the new version. Okay, so this is going to be 1.2 millimeters from the center of pin 1. Let's see, 1.4, 1.2, and then we have this line here. Let's make it 1.2. I'm just going to update this so that this is come on, 12. And then same thing here, 1.2 up, and just making sure that the silk, and this one is 11.8 long. Which I think, if I can remember correctly from the datasheet, I think this basically means, yeah, we should have 11.9 actually. Let's see, let's make this 11.9. Or actually it will be 12, because we have, let's see. Can we move this? Yeah. Let's see. So this would be actually aligned if we have a grid that is 0.5. So 2.75. Let's make sure this is 2.75. Maybe it's actually, is it 70? No, it's 45, right? So 245, like this. And this one is 245 from the 0 point here. And to me this seems like this is offset, in which case this is wrong. And it's really important to have the silk screen for placement, and I want the silk screen to be the size of the component. Let's move this slightly there, and then this one as well. So this explains why when let's see, 245, that's where 245 is. Okay. And then I want this to be at, let's see, maybe I can just, yeah, I can just make this 245. There we go. And then we have the fab layer, and we have the courtyard. I use both the courtyard for placement and also the silk screen. So I use the courtyard for the minimum distance, and then if I violate the courtyard, because sometimes I want to do that as close as possible, and I use the silk screen, and therefore it's important that the silk screen is precisely the size of the component, so that I don't place them too close. Then this one will be, let's see, I think this one will be 9.2. So actually, if we do, let's do like this. We select it, and then we have the endpoint on Y will be 8. So now we have 1.2 there, and then we have 8 going from the 0 point there. And then, let's see, this will go here, and this will be deleted, and this will go, let's see, here. Okay. And the courtyard on the PCB edge side is going to be aligned with the silk screen. All right, let's save this and update this. That's better. So now we can place them not fully like totally close, so I leave a little bit between the components, but at least I know that the component is not going to be protruding any more than this silk screen. So that's good. Now the next driver is going to be there. I can just move the ESD protection diodes as well. I'm going to move the, and we have 2 capacitors for each chip. One bypass capacitor for the 5 volts that is used for the Cantrons. One is for the other one is for the IO, the 3.3 volts that is feeding the interface to the microcontroller. let's grab that one. Okay. And we can align these two. And then the diode will just plug in there. So the diode can basically be just as close to the chip as possible. And it will be then, let's see, so the lines will then go to H and L. We want to avoid this crossing here. So obviously, because it doesn't matter from the connector side, these are screw terminals. So the whole idea is that you can plug in a cable directly to the plug that plugs into this connector. So it doesn't really matter what pinout they have. So we can easily change this to suit the layout. So let's do that. Let's see. This is a rather intrusive change, so I have to be very careful. I'm going to change this. I'm going to change this connector. Let's see. Let me just think what would be the best way to do this, because I also have to update this then, so that I can have the same wiring. But what if yeah, or I'll just do like this. So I'll just delete. I'll just edit this component and just change the numbers there, and this should produce the result I want. So I wire this one to number 2, and then this one will go to number 1. Let's see. Yeah, and then we have our annotation is correct on this connector. We just change the... Okay, cool. Update PCB from schematic, and we should get rid of this crossing now. Cool. All right, next is this kind of D interface, which has a similar connector. actually the same connector. So we can group all of the CAN interfaces right next to each other. And then there is exactly the same drives the actual wires. Let's see. And we have the bypass capacitors. Bypass capacitors will go like this. And the second one. And now this layout will make it easy to, let's see, is this actually correct? I think this one, no, actually this one is intended for the CAN interface chip. This one will go to the transceiver. So this layout will make it pairs. Not that CAN benefits much from being a differential pair on the PCB. It's not that fast. But anyway, even though it's a robust transmission protocol, I'll still use differential pair to route this. And this will just route directly to the pins. So it's going to be a nice differential pair of two signals going to the pins of the connector. Next, I'll just move the crystal and the two capacitors that are the loading capacitors. The loading capacitors of the crystal allow you to adjust the frequency with which the crystal is oscillating. Let me just check. Yeah, actually I have a meeting now, so I have to stop this video possibly. Let me just check something. I'm going to just finish up this placement of the capacitors video, so then I can just stop the stream. Let's see, so this will go here and this will go here on the other side of the crystal. Yep. And just moving the labels out of the way. The designators, that's what they're called. And this will go there. Let's see, this will go actually here. So we have, yeah, we have the bypass capacitor. I think we have everything now. I'm just gonna move this and these two test points. Test points go to the interrupt and the chip select. What is... Oh, okay, right. Yeah, this can be placed there. This is the standby. All right, and the next step would be just to place this in some reasonable way so that we minimize the area of this part of the PCB. Let's see if maybe rotating them would be better. Yeah, I think that I'll go with the rotation, but possibly the other way. Let's see. Yeah. And then we can just move this here. I really should just finish this first. Let's move them a bit closer, actually. Yep. And this one here. And then finally this one goes here. And I think it's better to actually just move them here like this. Yeah, it's quite likely gonna end up like something like that, but I really need to stop this video now. So you'll see my final layout in the next video, how I'm going to make sure that I save as much space as possible, because I'm not really happy with this. Right, I have